Hello everyone, welcome back. This is part 4 of the Solid Design Principles tutorial. In this session, we will discuss Open Closed Principle, implementation guidelines of Open Closed Principle, and will implement this principle with a simple example. Please refer to the previous parts of the tutorial before proceeding. In the first session of Solid Principles Introduction, we have understood that O in the solid is acronym for Open Closed Principle, which is also known as OCP. In the object-oriented programming, the Open Closed Principle states that software entities such as classes, modules, functions, etc. should be open for extension but closed for modification, which means any new functionality should be implemented by adding new classes, attributes, and methods instead of changing the current ones or existing ones. Bertrand Meyer is generally credited for having originated the term open closed principle, and this principle is considered by Bob Martin as the most important principle of object oriented design. Let's now take a look at the implementation guidelines of this principle. The simplest way to apply open close principle is to implement the new functionality on new derived subclasses that inherit the original class implementation. Another way is to allow client to access the original class with an abstract interface. So at any given point of time, when there is a requirement change, instead of touching the existing functionality, it is always suggested to create new classes and leave the original implementation untouched. Now you may be wondering why we need to follow the open close principle. Let's approach this argument with a counter stating that what if I do not follow open close principle during a requirement enhancement in the development process? In that case, we end up with the following disadvantages. If a class or a function always allows the addition of new logic, as a developer, we end up testing the entire functionality along with the requirement. Also, as a developer, we need to ensure to communicate the scope of changes to the quality assurance team in advance so that they can gear up for enhanced regression testing along with the feature testing. Obviously, this is a costly process to adapt for any organization. Not following the open closure principle breaks the single responsibility principle as well, since a class or function might end up doing multiple tasks. From this, we can state that both single responsibility and open close principles are highly dependent on each other. Also, if the changes are implemented on the same class, maintenance of the class becomes difficult since the code of the class increases by thousands of unorganized lines. I hope that these counterfacts helps in understanding on why we need to follow the open close principle. Let's now switch to the Visual Studio and bring up a console application to demonstrate how we can implement open close principle. To save some time, I have already created a console application. Let's take an example requirement which states that we need to compute bonus of an employee. In a typical scenario, as a developer, we tend to create an employee class with ID and name as the properties of the employee. And then we tend to create a method to compute the bonus of an employee. This code works great, and we will be able to see the output in the console once we run this application. Let's run this application. Notice that the employee John has been awarded a bonus of 10%. Let's stop this application. Let's say now there is an enhancement or a new requirement to differentiate bonus for permanent and contract employees. In a typical scenario, we tend to modify the class by adding an employee type property and enhance the current method to account for the employee type while computing the bonus. Let's see how we need to achieve that requirement. Let's create a new property, public string employee type, and then let's add this employee type in the constructor, string employee type, and assign this value with this dot employee type equal to employee type. While calculating the bonus, we need to verify if the given employee is a permanent or contract. Let's say if this dot employee type equal to permanent, the bonus would be 10%. Else, the bonus would be 5%, which is applicable for the contract employees. Let's switch to the main program and do the necessary changes over there. Look at that. It's already throwing an error to pass the employee type. So let's pass permanent as the employee type. Let's also create a new employee called Jason. Let's change his name. Jason with employee ID 2 and who is a temporary employee. Let's also print the employee bonus of Jason as well. Let's change the employee John to employee Jason and let's calculate the employee Jason bonus with a different salary. Let's run this application. Notice that the bonus of John and Jason are computed based on the requirement. As a developer, we are happy as the code is working as expected. But remember, we have changed the method to support the new requirement. Further, if we need to add more requirements in future, we end up enhancing the same method to support new requirements. Hence, we can say that this class is not closed for modification, and we end up with all those issues that we discussed in the beginning of this session for not following the open-closed principle. Now, if you are wondering how to address this issue, it's very simple. Let's see how we can achieve that. The first thing to change is to make the employee class as an abstract class and leave the implementation of the bonus to the derived classes. This helps in extending the class for further enhancements without touching the base class. Please note that depending on the situation, we need to opt for an interface or an abstract class. In this situation, I'm choosing an abstract class which fits the requirement. Let's change this class to abstract class, abstract class employee. Let's also remove this employee type from the constructor as well. And let's make this calculate bonus as an abstract method, abstract decimal. And let's remove this implementation and move this implementation to the derived classes. Notice that we have got a structure of an abstract base class. Now, as per the requirement, we need to create a permanent employee and calculate his bonus. Let's see how we can do that. Let's create public class permanent employee and let's inherit this abstract employee class. Let's fix these issues by implementing the abstract class. In this situation, we need to return the bonus of permanent employee, which is salary dot 10% of it, which will be dot 1. Let's also create a constructor for this permanent employee. Notice that we have created two constructors, and the second one consists of input parameter, and we are assigning those values using the base class. Let's switch to the main program and do the necessary changes. Instead of creating a new employee, we will create a permanent employee class. In this situation for Jason, it will be a temporary employee class. Let's knock off this employee type. Let's run this application. Notice that the bonus of employee John and Jason remained unchanged. Also, we can say that the employee class is now open for extension and closed for modification, adhering to the open closure principle. I believe now you have a good idea on implementing the open closure principle. In the next session, we will focus on Liskov substitution principle. Thank you for listening and have a great day.